Hello, today we'll be doing an introduction on and, or, and not logic gates. We'll start off with the notation, then we'll go to the truth table, and we'll end with the logic gate and what that looks like. Let's start off with and. And, if you're doing A and B, is going to be represented with a multiplication sign or a little dot. Going into the truth table for this, you can think of it as A and B have to be true for the output to be true. So F, for that to be true, A and B both have to be true. So true, true, that means that we get true. A and B are true, then it's true. If not, it's false. A and B, right? So A and B are only true together for that one example on the truth table. Moving on to or, we've got A or B. That's going to be represented with a plus sign. So multiplication for and, or is going to be plus sign. Going into the truth table, A or B has to be true for the output to be true. So A or B have to be true. They're both true in this case, that works. A or B has to be true. A is true, so our output is true. A or B, A or B. Here, neither of them are true, so A or B doesn't work, so that's a 0. You can notice that there's 3 zeros here and 3 ones here, so they're almost kind of the inverse of each other, but not quite. But that's an easy way to see it on the truth table. Moving on to our last logic gate, we have not. That can be shown as a dash, which is what we showed in the K-maps examples. Go ahead and check those out if you haven't seen them. Or a bar. Those both represent not A. The truth table for this is extremely simple. A not is just the opposite of whatever it is, so it'll go 0 to 1 and 1 to 0. Moving on to what the logic gates look like. And is going to be a nice half circle with the output coming out, which is F, and A and B going in. So this is and. And that's what that looks like. So if A is 1 and B is 0, A is 1, B is 0, our output is 0. Moving on to or. Or looks like a Star Trek symbol. If you've watched it, just sideways. We've got A and B here with our output coming out, and that's F. So that's what our or looks like. If A is 1 and B is 0, our output is 1. And for our last logic gate, we have not. Not is a triangle with a little bow at the end. So you'll have A going in and F coming out. So if A is 1, F is 0. If A is 0, F is 1. And that's logic gate for not. Thanks for watching, and stick around for NAND, NOR, and XOR, which will be in a later video. Thanks for watching.